This involves some of our standing for the motion of the heavenly body. Okay? Now, think about, previously we were all talking about the two-body problem. Okay. The sun and the earth, or the earth and the satellite. And in reality, we may need to deal with more than two objects. For example, the three-body problem. Think about when you launch the satellite. In fact, you need to consider both the sun, the earth, okay, and the satellite itself. Okay? So you actually have three bodies. 1, 2, 3. And we mentioned that for three-body problem, in general, it's not solvable. Okay? It's very difficult to solve the three-body problem exactly. But we can still talking about some spatial case or spatial point. Okay? LaGrange points are some of those spatial points. What's special about the Lagrangian points is that there are 5 Lagrangian points. We call them L1, L through L5. For these 5 points, the satellite can be, okay, these points can be relatively stable. It can be stay there relative to the two main objects, the sun and the earth. So that means relative to the sun and the earth, its position will not change. It's fixed there. Okay. So they have 5 points called L1, L2, L3, and L4 and L5. Okay. It shows the relative position in the sun-earth system. Okay. The L1 is the most simple one to understand. It's about here. Because you can think about the gravitational from the sun and the earth. The gravitational force from the sun if the satellite is here, okay? So it's in this direction. And the gravitational force from the earth is in this direction. So depending on the location, it's possible the two forces will cancel each other exactly. So there is no net force acted on the satellite here. So if satellite is located here, it will stay there. Okay. So this is L1, the most simple one. Now think about L2. L2 is here. The gravitational force acted on L2 point, if you have a satellite here. From the sun, it's attractive force to this direction. From the earth, it's also in this direction, right? So can you see that the two forces can never cancel each other? So there is some net force acting on L2. So how can L2 be a fixed point? The issue here is that it can only be fixed there, or it can only be in an equilibrium in the sense of dynamic equilibrium. This one is called the static equilibrium. So that means even in a static situation, even the sun and the earth are not moving, okay, it can still be there. But for this point, L2 is a dynamical equilibrium. So it can be fixed in the sense that this one will move with in the same pace of the earth. So both of them moving like that. So it's just like the geostationary orbits like so. When the earth moves to here, the satellite will move to here. This is possible, okay, if the gravitational force, the summation of the gravitational force here is appropriate to provide the required centripetal acceleration to maintain the same period for the Earth and the satellite. This is possible, right? Okay. So, in fact, if we want to do the calculation, the equation, you can write it. So, if you have the gravitational F1, F2, so it should be F1 plus F2 equals to MAC. And so you get G, capital M, S, M. This M is the mass of the satellite. This is ME. This is MS. Okay. Divided by, if this is R2, okay, R1, this is R2, so divided by R1 squared plus R2 squared, and equals to mv squared over R1. Okay, the rotational radius is R1. And then you can fix V by introduce the period T equals to 2 pi R1 over V. Okay. So V equals to 2 pi R1 over T, and T here should be the, what's T here if you want to calculate it? It should be the period of the Earth for one rotation. What's that? 1 year. Okay, you input 1 year here. That's the rotation about the sun. It's not 24 hours. It's not 1 day. It should be 1 year. Okay, and then you can calculate that these quantities. Okay, but we're not going to use calculate. We just say this possible. Similarly, you have L3 here. Okay, again, if you arrange the two gravitational force exactly provides the needed centripetal acceleration for 1 year period rotation. Okay, so this you can have another point here. One more point is two more points, L4 and L5. Okay, I'm not going to discuss them in details because it's much more complicated than that. In this case, you need to combine the two gravitational force in the vector fashion. Okay, but still possible. So totally, you have 4 stationary points. Okay, so the first one, L1, is absolute static equilibrium. L2, L3, L4, and L5, they are dynamic equilibrium. All of them only possible if the whole system is in rotation. Okay. But interestingly is that actually L1, L2, and L3, they are not very stable. Okay. The satellite cannot stay there completely for a long time. Usually, they need to make some small circular motion around L1, L2 there. But L5, L4, these 2 points are stable points. So the satellite can actually locate there for a very long time. And these different LaGrange points, they actually have different kind of application. Think about if you want to send some satellite or space station to observe the sun, L1 will be a good point, okay? Because at any time it will not be shadowed by the Earth. Okay, so you can always observe the sun for the whole year. And if you want to make some space station to observe the deep space, L2 will be a good point because then the light from the sun will be blocked by the Earth, so it will not interrupt the observation of the L2 here. L3 is quite famous in the fiction because from the Earth you can never see area 3. So if something happens in area 3, you cannot see it. So in the science fiction, usually they place another Earth here. It's called the counter Earth here. Okay. But now we know that nothing in area 3, the Sun Earth system. And area 4 and area 5, it's special because they are stable points. So they will attract usually some object here, like in the Sun-Jupiter system, L4 and L4 points, they attract some small objects. So they have a lot of asteroids at these points. Okay? So that's the LaGrange point. Let's stop here.
Bunch of kids that's not going to be on the test.
Yeah, I know, right?
That's the way I think about that.